Hello everyone, hope you've had a good week. Expect more frequent uploads as I finally figured out how to cheat my schedule and upload every week, every Saturday now. It's been a while since I've done a 3D printing video and now I'm resuming my old projects and playlists and a ton of new content coming soon. Over the summer I'm going to learn Fusion 360 for good so I can use a more advanced software than Tinkercad, which I virtually mastered over the past 2 years. This video, the multiplication tables box, is the second installment in the 3D printed math aids playlist, the first being the fraction manipulatives video, which it feels like I just filmed yesterday, but it was actually nearly 2 years ago, September of 2020, so there. That product was for students in the lower grades who are learning fractions, to learn fractions in a visible and tangible, physical way using pieces of an inedible pie to fit together in a folder which represents one whole. The drive link to that product is included in that video's link, which is also the previous video in this playlist. Anyways, back to the topic. This product is a multiplication tables box. It is meant for students as young as grade 2 and as old as grade 6. Meant for students who are learning their multiplication tables, though people of any age could theoretically use it. So what exactly does that mean? So basically, if you saw in the title slide, it's made up of a board and 144 tiles, as you can see. It's a 12 by 12 grid and you have to slot the numbers into the right places looking at the top edge and left edge to figure out where to put the tile. It's a grid system. Let's say you draw the tile out of your container that says number 4. You can put it in one of 3 places. The tile slot that's 4 units to the right and 1 unit down, that's 4 times 1. You can put it in the tile slot that's 2 units down and 2 units to the right, that's 2 times 2. Or you can put it in the tile slot that's 4 units down and 1 unit to the right, that is 1 times 4. Or let's say you drew a tile that was number 1. You can only really put it in one place, that's the 1 tile down, 1 tile to the right, 1 times 1. You drew a tile that says 144, you can also put that only in one place, 12 by 12. You can do it at your own pace, or even time yourself, see how long it takes you to put all 144 tiles in the right positions. Or you can even play against a friend, where you draw one tile at a time, log how many tiles you've drawn, and the winner is the one with the most tiles. Or you can do it separately, and your friend does it separately, and the winner is the one with the fastest time. This product has a total of 150 pieces. The board is divided into quarters, which are to be printed out individually. That's 4 pieces right there, plus 144 tiles, that's 148. You get a sheet of sticker paper to put the numbers on the tiles. Actually, the Word document that I gave you, I do not give you the sticker paper. That's 149, and for a nice round number and a test print to make sure your 3D printer is working okay, throw in a bonus tile, and that's 150. Takes a lot less time to print than you think, and I'll show you in the next slide. There are 4 quarter parts, as I've shown you right over here. Each quarter part takes an average of about 6 hours to print. The top one with the most numbers on it takes the most time. These two take roughly the same amount of time. See, there's only one row of numbers. And the one on the bottom with no numbers on it, that takes the least amount of time, just 5 hours and 53 minutes. Each quarter of a board is a 6 by 6 grid, slightly different, and I'll take an average of about 6 hours. And the tiles, there's 144 of them, so printing them all out one by one is really going to be a pain. So I've saved you some time and grouped them all into 36. So you print that same file out 4 times, right there. Each of those 36 tile sets takes about 3 hours and 15 minutes to print, which takes about 13 hours to print. So, yeah. Take that same file and print it over and over 4 times. And also, just to check that everything works okay with the printer, print the bonus tile first. The slicer says that it takes about 10 minutes, but usually takes a little bit shorter actually printing, because the printer takes a while to heat up. That's actually included in 10 minutes. Just to let you know, each quarter does not have the tiles already slotted into it by default. You have to print them out separately. My photo may be a bit misleading, and I'll show you how they slot in the gallery, which is coming a bit later. It's kind of obvious to me, at least to me, how to put the parts together, but I'll explain here just in case. first, you've got to 3D print this stuff. Slice it using a slicer software like Cura, then print it. Don't have a 3D printer, ask someone else who does to do it for you. Remove the scaffolding, which is a really long process. I'll get to that later. Next, once you've got all the scaffolding free parts cleaned up, sanded, you need to glue them together along the edges as shown in the diagram alongside the inside edges. I personally recommend super glue, though you can use any strong glue. Hot glue definitely won't work for 3D printed material. I've tried, it just collapses and it just breaks apart after a while. Next, print out the Word document that I've given you. Print it out on sticker paper, cut it along the black lines. Paste one sticker on each of the 144 tiles. If you don't have sticker paper, you can print the document out on regular paper, cut, and use regular glue. This is less effective, still works, but just expect it'll have a shorter lifespan. It'll peel in a couple of months if you use it frequently. Also use some kind of container or bag to hold your tiles because there's 144 of them. They're very tiny and they can get lost easily. And step 4, enjoy. Print time. Everything will take about a day and a half to print. The board parts take a total of roughly 24 hours, although a bit more than that actually, maybe around 25 or even 26 hours. Just an approximation. 36 tile set takes approximately 13 hours actually. I just rounded it off and that's why there's an hour less. And this print time is only with very specific technical specifications. All the parts have to be set to 20% infill. That's the board parts, like the 4 quarters I showed you that make the main board. All those have to be set to 20% infill, which basically means 20% plastic filled with 80% air, which is very efficient and solid. You do not need any more than 20% infill for most prints, which in 20% infill, it's actually really efficient because it's like a beecomb structure, beehive, honeycomb. It's like a hexagon or a rectangular or triangular grid work that goes straight up, and it's just very, very stable. Even though the air is there, it's just the way it's just put together. You don't need any more than 20% plastic. Though the 36 tiles are very smaller, so set them to 80% infill so they're more stable and don't break apart easily. Though I think even with 20% infill, the tiles should be fairly stable. So yeah, there. Each of the board parts would take a slightly different amount of time, as I mentioned earlier, and yes. I'll mention scaffolding right now. Scaffolding is a real pain in the neck. It's supposed to make your life easier, and it's basically a brim or raft on the lowest layer of the print, which makes it easier to remove from the print bed once done. This can be enabled in the slicer settings. Click the adhesion box right there in Cura. It's basically the teal or light blue, whatever color that is, layer of stuff on the lower layer of the print. You have to scrape that off using a metal spatula, or I forgot what that thing is called, like a scraper, I guess. It does make it a lot easier to pop off the print, and it winds up with a lot less damage to the print bed itself, but it's kind of hard to get off the print itself. You have to either scrape it off by hand or use a scissor, and you wind up with a lot of wasted filament, especially for models with a lot of pieces in it, like this one, which is 150 pieces. I ended up with a Ziploc bag size amount of scaffolding, which might not sound like much, but is a lot. Is the most amount of scaffolding I've got for any print. And you've got to consider that each individual tile of the 144 has a brim that's twice the size of the tile itself. And you'll see what I mean. But what's cool here, though, is that there are machines which exist, like RecycleBot, which convert shredded thermoplastic, like PLA and ABS, back into filament. That includes the scaffolding too, that's the same plastic. As well as any recyclable plastic shredded, like those in plastic bottles, containers, etc. Like, it has to be shredded beforehand using a certain other machine. And it's a fairly time-consuming process, but like if you're interested, take a look at the link included. It's not really in mainstream public use yet. I have to wait a while till it becomes common, but if you're interested, take a look at it. I guess you can still buy it. I guess it's still expensive though. And here's an example of the actual scaffolding in real life. I cut a bit there, but before I knew I was gonna take a photo of it, so that's why. It doesn't actually have that line. That's how it is. That's a lot of scaffolding for one tiny tile. And yeah, we are finally pretty much done with the video. I'm just going to show you some photos of the multiplication tables box. You have to separate in board parts before gluing. All the tiles are in them, so I recommend you take out the tiles first before gluing, just in case. You don't want one of the tiles just glued to your board by accident. That just takes the fun out of it. There's one of the board pieces with a couple of tiles on it, and there's many tiles off to the side. This is how it slots in. There's an indent where each tile is supposed to be. Each of the 4 quarters is a 6 by 6 grid, and you slot each of the tiles into them, and you print out the sticker paper, cut along lines, etc. And yeah, you just put them in, and it's yeah. Here's the finished product with some of the tiles added into it. The sticker paper is already added onto it. You can have to slot it into the tiles. They're all in the right positions. There's some tiles off to the side there. It's a bit cut off, but yeah, whatever. Here's the last image. All the parts together before assembly, and obviously some of the tiles are not here, because if you can count, that is definitely not all 144 tiles. Or actually, maybe it is, because all the tiles are actually slotted into here. My bad. Anyways, so you have to cut along the black line. Then you have to print them out on sticker paper. That sticker paper right there, and you have to cut them out and paste them onto each of the tiles, which is a long and painstaking process. And yeah, we're almost done here. Here's the drive link. It's in the description right here, or you can pause this video and type it into your search box. And right about now, we are done with this video. If you were counting, that was exactly 13 slides, which is supposed to be unlucky, but I'm not superstitious. And anyways, I hope you enjoyed this video. Stay tuned for more uploads, which are coming every Saturday, and have a great day and the rest of your weekend.